Good evening, folks. What you're about to see is something you've never seen before. The video feedback Fractal device has finally achieved 4K resolution, something I didn't think would ever be possible. That's because to do precision analog optical video feedback, you need analog knobs. The hue, saturation, brightness, and contrast knobs that are usually only found on old standard definition TV sets. The previous HD iteration of the feedback device was possible because I had found specialized HD monitors that did have those knobs, but 4K screens with knobs like that, except for very expensive color grading monitors, they just don't exist. So I had to create them myself. Okay, this is it. The whole enchilada. The whole ball of wax. 4K monitor with true analog potentiometers. Hue, saturation, brightness, and contrast. This video will be an explanation of what optical analog video feedback is, how this 4K 60 frames per second version was built and what its various buttons and knobs do, plus a history of its evolution. And throughout there'll be short interludes showing some of the first 4K feedback created with the device. And at the very end there's an extended light herding session that I think turned out pretty good. Oh, and I'll explain why I set a tuba on fire, and how to capture its image in a feedback loop. I have to say thank you to Austin White, who owns the Device Lab electronics repair shop in California. He saw my video back in 2024 where I talked about wanting to go from HD to 4K and not thinking it was possible. Unfortunately, it's just not possible to do this in 4K. There really aren't 4K monitors with analog knobs. If someone knows where to find something like this, let me know. He contacted me and did let me know about his idea for making 4K screens controllable with analog knobs. So how it works is there's a little microcontroller in here. It's called the Teensy, and it really is teensy tiny. Here's the microcontroller running C++. Here's a little extender for that. And here's the power supply for these little things that convert the Teensy signal to RS-232. And what's happening is the microcontroller is converting the analog signal from the knobs to digital and sending it out to the video control boards. And I'm still waiting on the 5 EDP cables that connect the 4K screens to the control boards to be manufactured. But in the meantime, Renato at Digital View was nice enough to send one over so I can finally do this proof of concept. This is the video control board. This goes into the little mahogany boxes where the monitor sits. And all this has to be smushed up in there. I hope that can be done. All right, an update. I got everything in the control box and everything works. I saved a lot of space because I got rid of these larger Max 323 components. I substituted those for the mini version. You can see they're much smaller, and they're actually all in here. I've seen some videos where people do things very professional looking. I opt more for use a lot of tape and solder and hope for the best. After spending so much time on this project, I was worried about the final results. Would it be worth it? Would it even work? Well, it actually does work, and I think the images are pretty amazing. And I've just really begun to figure out how to use the thing. And to be clear, there are people using software to make beautiful non-analog, non-optical 4K feedback images. But to my knowledge, this is the first precision-controlled optical analog 4K video feedback, where the operator at the helm of the device is actually part of the feedback loop, adjusting the hue, saturation, brightness, and contrast knobs for each of the 5 4K monitors, moving the cameras smoothly back and forth in 360 degrees around, creating fractals in real time without a computer. Some of the shapes are familiar from the HD version, but the depth and fine detail, the number of recursive iterations visible on the screen at once, is at a whole different level. A session using the device, staring into the 4K viewing monitors, watching these images emerge, is truly a hypnotic experience. And sometimes it almost feels like you're seeing some secrets of the universe being revealed. After all, the key to consciousness is most likely recursion. And it's no wonder there's such an amazing difference from the HD version. Considering those special HD Panasonic monitors, the ones I found with the analog knobs, they were older technology with a resolution of just 1280 by 720, not even the standard for HD today of 1920 by 1080. So the increase in resolution of the 4K device is vast. But what is analog optical video feedback? You might be asking yourself, or maybe your cat. And how am I getting fractals? And why do I say it's all done without a computer, when clearly there are computer chips in the cameras and video control boards and the switcher and routers and the control box? I'll go into everything this custom control box does a little later in the video. Video feedback is what happens when you point a camera at a monitor displaying the output of that camera. This is like audio feedback, where a microphone picks up the sound coming from the speaker, making that screeching noise. Here, video feedback is being made with a vintage 1978 Kmart TV set. Because it's a black and white set, it just has the brightness and contrast knobs, no hue or color saturation, but it's these knobs that are all important. It's how you dial in the image, keeping it from going completely white or disappearing and going completely black. It's this middle zone where interesting things happen in video feedback and in life. With these old standard definition cathode ray tube TV sets, it's pretty easy to create long-lasting, self-sustaining patterns like these. But with modern LCD screens in HD, and now especially in 4K, maintaining this delicate balance, this all-important middle space, is like finding that tiny zone on a light switch between on and off where interesting things happen. Getting it just right takes a lot of patience and practice. Tiny movements of the knobs. The cool patterns are elusive and tend to want to disappear shortly after they show themselves. But it's when you find that sweet spot, that balance of color, brightness, and contrast, that those secrets I mentioned earlier show themselves.
There's no limit to what I feel. We climb higher and higher. Am I dreaming, or is this all real? Is it true I'm an eagle? Is it true I can spread my wings? Flying high, high. I'm a bird in the sky. I'm an eagle that rides on the breeze. High, high. What a feeling to fly over mountains and forests and seas, and to go anywhere that I please.
So it's the light traveling from the screen through space, through the camera's lens, along with the physical movement of the cameras, the turning of the knobs, this iterative, recursive process creating the patterns, rather than a numerical computational process that makes this analog and optical feedback. And why I say it's not created with a computer. There's no algorithm, no software, just physics. So these are the two main cameras and the two monitor structures with the four 4K screens. There's an additional camera here and another 4K screen here. This camera is seeing this image in this screen and also this image in this screen reflected in this 50/50 teleprompter glass. And this camera is seeing the image on this screen and the image on this screen reflected in this glass. And it's this piece of teleprompter glass that acts as a physical mixer, folding the image back onto itself, that makes creating actual fractals possible, not just video feedback. Shout out to Peter King of Sweet and Fizzy and his post from 1997 that put me on the road to creating fractals this way. So looking at the schematic here, each screen either gets an input directly from a camera or from the switcher. And the switcher is either getting an input from a camera or from somewhere else. And I'll talk about the 4K switcher I'm using and its importance a bit later in the video. The two cameras are mounted on aluminum rods, and they're locked together linearly, but they can spin using this tiller here, and they can move very smoothly back and forth through these linear bearings here and here. These are genuine German Linearkugellagers. These work by recirculating metal ball bearings along the track. These kind of bearings are always in some kind of housing, but a big industrial housing like this wasn't going to work for me. I came up with the idea of using a rotational bearing around the linear bearing, so the rotational bearing acts as the housing, then the linear bearing spins within inside the rotational bearing. Has this ever been done before? So what is actually going on here though? What is this making? Well, I can make these fractals here like this in real time by moving the rod in and out and turning it around like this, and by dialing in very precisely with these analog knobs. But you're probably wondering what's the purpose of the two cameras and the two rods linked together. The device originally had one camera and one rod and got a secondary input from the phone, but I wanted a way to give that secondary input some motion. When I first started using the secondary input, that object was very static, and I wanted to give it some organic motion. Not just putting motion on it in After Effects or something, but motion that was somehow connected with the rest of the device. I came up with the idea of maybe rotating a second camera, but decided it would be easier to rotate the object itself. The tricky part was how to make that second rod rotate and move forward and back with the first rod. I went with a Van de Graaff generator belt for the rotation, and these PVC parts here with these little screws to catch the linear motion. And you don't need to use the blue screen. And now that input can be an actual fractal. And you can integrate this fractal over here and this fractal over there and make them part of each other.
Sunshine, baby. It's a rainy day. Sunshine, baby. It's a rainy day. Sunshine, girl. It's a rainy day. Sunshine, girl.
One of the key principles of the feedback device is capturing an image in a feedback loop, or making an image go into a fractal. And I'm going to illustrate what I mean by trapping an image in a feedback loop by capturing this image of a tuba that I set on fire as an homage to the painting The Fair Captive by René Magritte that was used in the 1979 book Gödel Escher Bach, An Eternal Golden Braid, where Douglas Hofstadter uses this painting to describe what recursion is and to explain what video feedback is. It's this book that I read in high school that got me interested in feedback and all things recursive and self-referential. Here's my friend Ty Hardaway and me in my dorm room at UC Santa Cruz in 1988, making video feedback for the first time, using my little TV that did have those all-important hue, saturation, contrast, and brightness knobs. And it was in 1989 that I first had the idea that you could actually trap images in a feedback loop by quickly switching the image going to the screen from an external source to the camera's output. Here, that external source is my face recorded on VHS. At first, I used an electric relay to make the switch between external source and camera output. Then in 1990, I graduated to the WJ-MX12 switcher for a clean and instant glitch-free switch. Okay, that's enough of that. So, trapping Magritte's flaming tuba in a feedback loop. Right now, this image of the tuba is coming from the NVIDIA Shield, which is a little box that I'm using to display photos and 4K videos as a source. The camera is just seeing the tuba. There's no feedback loop happening. But when I press the switcher's cut button on the control box or press the foot pedal, which does the same thing, the screen no longer gets its input from the Shield playback unit, but from the camera looking at the screen. And in that split second, that image of the tuba is still in the pipeline of the cables, the switcher, the various processors, and gets displayed on the screen, which is then seen by the camera, which now gets displayed on the screen, which is seen by the camera, over and over. So that image becomes the seed for the feedback loop, each iteration getting more and more degraded. But the interesting thing is, when the camera, the knobs, the monitors, everything is positioned just right, you can get the image to persist for a pretty long time. We'll capture the fair captive in a feedback loop and go into Magritte's canvas, within the canvas, within the camera, within the screen, within the canvas, within the screen. Here's a painting by Savannah artist David Laughlin, The Old Man and the Tuba. It's getting trapped in a feedback loop. Let's trap this dog in a feedback loop. How about this chicken man of Portugal? And that's pretty cool. This image is no longer coming from any source. It just exists in the wires and the equipment, going round and round in there. And if there was no air gap, no lenses, that image would just stay in that loop perfectly forever. I think this must be how consciousness works. A pattern that develops recursively over time. Who you are is this pattern and not the physical wiring of the neurons in your brain. Or maybe I'm totally wrong. I don't know. And check this out. When I dial in some video delay, I can slow down the degradation of the image by varying degrees. I'll talk more a bit later in the video about these really cool PVD 1400 delay boxes donated to the 4K Lighthorder project by Lynx Technic USA.
We're only making plans for Nigel. Nigel just needs this helping hand. must be happy, he must be happy in his world. We're only making plans for Nigel. We only want what's best for him. We're only making plans for Nigel. Nigel just needs this helping hand.
You can use the front camera, which usually makes feedback with the rotating monitor, to incorporate a physical object, like this little flower. Or you can point the front camera at a live performance and someone strumming a guitar. You could use a logo as an input, or text from a poem. I mentioned before that an image can not only be trapped in a feedback loop, but can be put into a fractal. So right now there's a feedback loop between this camera and the upper screen here on the right monitor structure. And the image on the lower screen of the flaming tuba is getting mixed in by way of the glass. And that combined image from this structure is being sent over to the lower screen on this monitor structure, where there's a feedback loop between this camera and the upper screen here. And that image from the right monitor structure is getting mixed in through the glass. But just like before, when I press the cut button on the control box, that image on the lower screen will no longer come from this monitor structure, but from this camera itself. And that image will get mixed in with the top one through the glass and go into a fractal. And that's when things get more interesting. I now have the inputs on these three MEs or switchers in what I call insanity mode, for lack of a better term. And what's happening is there's not only a feedback loop between this camera and this monitor structure, and this camera and this monitor structure, but between the two monitor structures themselves. So what this camera sees over here is being placed on this lower screen here, and what this camera sees over here is being placed on this lower screen there. So anything that happens on any of these screens affects all the other screens. So it's really hard to maintain anything without everything going into complete chaos. And you can see that this shape is in this pattern, while this shape is in this pattern. This one's making this one, while this one's making that one. They're both making each other. And that's really weird.
Radioactivity is in the air for you and me. Radioactivity discovered by Madame Curie.
Now we'll take a look at what's at the heart of the device, the 4K switcher and the custom control box. I have to replace each of these HD switchers with a 4K switcher, and I thought it was going to be really expensive because there are 4 of them and they don't make cheap little 4K switchers like they make these HD switchers. But each one of these has 2 inputs and 1 output. They're each triggered by a switch here, so you switch between input 1 or 2 or on the foot pedal. So here's the solution for the 4 4K switchers, and it's all actually working now, which is pretty amazing. It's been hours getting this to work. But this is a 4ME 4K switcher, and that means basically 4 switchers in one box here. I got this used for 1/7 of the price of this new. These things are really expensive. And it's appropriate, the switcher is named Atem. Black magic says that's derived from Atum, the Egyptian god of creation. Atum meaning to finish or to complete. See you, Bonkers. And this is the box that has all the analog knobs for the 4 monitors. Waiting on some knob caps here, coming soon. And everything goes to the Raspberry Pi running Python, which talks to the switcher by Ethernet cable. And here are the 4 momentary switches like before, switching between inputs of the 4 switchers or 4 mix effects. And so I can switch between input 1 and 2. When I switch this over, I'm cutting between 2 and 1. And of course, a foot pedal for each one of the momentary switches. When you put the second switch up, you get the chroma key. And when the second switch is in the down position, it's the luma key. Well, you might be thinking, what's up with the knobs? Isn't that the most important part? Why are you messing around with all this stuff? Shouldn't you be doing the knobs? That's what all these wires are for. But the holdup is getting the 40-pin cable that goes from the video board to this screen. And you can't just get this on Amazon. Edge Electronics is having 5 made somewhere in China, and it has a 7 to 11 week lead time. Stand by for 7 to 11 weeks. That is, if it all works. The previous HD switchers were controlled through a simple phono plug. You could just tell it to make the cut through the foot pedal or push button. Now this new ability to control the 4K switcher with software through Ethernet cable opened up a whole new world of possibilities. And because of the wait time for those cables to arrive, I had a lot of time to come up with ideas for different features. The new addition, rhythmic switching on switcher 1 and switcher 2. Enter pattern here. There's quantize mode. Enter a beat. Now these are quantized and synced with each other to a 16th. I just added these rotary knobs as another way of automating switching. Had to add a little extender board for the Raspberry Pi. I don't think everything's going to fit in the box anymore. This controls the length of the cut and the length of the total period. Turn this up. What I have installed now is this 4K router. Had to put another extender for the Pi. And what this does is it fills out these row switches here. And this is just a simple selecting a source, 1 or 2, on each of the 4 monitors and the 2 monitor structures. And there's also the flip. But the other great thing with this router is you can go from 60 frames a second, very smooth, select the frame right here, and 24 frames a second. More stuttery. Now the new feature is clip and gain, but here you get into that by pressing and holding these 2. It's just a way of adjusting how the key is coming in. And now there's this box, just recently added, and it controls 2 frame delay units. 1 frame delay unit is for this side and this loop, and 1 is for this side and this loop. And they're called the PVD 1400s from Lynx Technic. I can dial in from 0 to 30 frames, and it mimics the rotary encoder that's already on the unit. The German engineers did a great job in making this really difficult to figure out how to disassemble with a million little screws. And I've got a rotary encoder wired in parallel to this one. You push here, that chooses frame, and you rotate to add the delay. And this box also has that little teensy microcontroller in it, which allow these switches to control a router from Blackmagic, which puts the delay in various places along the signal flow. Thank you again to Steve Russell at Lynx Technic USA for donating these 2 units to the Lighthearter project. Here's some video delay in action.
We'll sing a song of birds and beds and slippery skin. Let's make our heads explode and fill the storm with blindness. The rain will swirl us away and wash out our dirty minds.
just uploaded some new code to the teensy microcontroller that's in the control box here with a new feature that allows you to program and automate the hue, brightness, contrast, saturation knobs for the 5 4K screens. And I'm doing this because of a new technique I've been using, where I take one of the brightness knobs and I turn it down to 0 like this. In this case, it's the lower screen on the right monitor structure. You can see it going to black. And this is really just fading out the video source. The thing is, if my hand is here fading to black on this brightness knob, it's not free to do anything else with any of the other knobs. So I wanted to get a way of automating any of the knobs. Now it's ready to record any of these knobs. So if I go like this, it's recording these movements. When I'm done, it'll play that back.
Even the greatest stars discover themselves in the looking glass. Sogar die größten Stars entdecken sich selbst im Spiegelglas. The artist is living in the mirror with the echoes of himself. Sogar die größten Stars machen sich zurecht im Looking Glass.
So this is what's in the base of the device. 4ME video switcher, 4x4 matrix router, 10x10 matrix router, 2x2 matrix router, video delay boxes, 4K playback unit, Ethernet switch, splitters and various SDI to HDMI, HDMI to SDI converters, but it still transports relatively easily. Everything is affixed to the bottom and the two halves fold together like a clam. The video feedback device has come a long way from the first experiments with feedback in the 80s, to trapping images in recursion loops in the 90s, to putting a little Sony Mavica camera on a wooden rod going through a PVC tube mounted on the ceiling in 2003, to finding the HD Panasonic monitors with those all-important knobs in 2019, and building the first iteration of the device with just one camera and one monitor structure, and getting these organic light creatures that I never thought would emerge. And since then, the device has evolved. A switcher was added, so another input from the phone could be used to influence the feedback. Then, to give this input some motion, a second rod linked to the first and a second camera was added. And to be able to have this second input itself go into feedback, and have that feedback loop influence the first feedback loop, a second switcher was added, and a third HD Panasonic monitor. Then a complete second monitor structure was added. And to make room for two of them, I constructed them out of T-slot aluminum. Then a third switcher was added, so there could be a feedback loop between the monitor structures themselves. And then on the front, a rotating Panasonic monitor and a third camera. And then rebuilding the entire device using maple and mahogany, learning how to use the planer, the jointer, how to make dovetail joints, making curved parts using the CNC router, going from wooden rods through aluminum tubing to aluminum rods through linear bearings mounted inside rotational bearings. And now, truly, the final iteration. And this time I mean it. The 4K video feedback Fractal device. 8K, anyone? Just kidding.
It's not the red of the dying sun, the moaning sheet's surprising stain. It's not the red of which we bleed. A red of Cabernet Sauvignon, a world of ruby, all in vain. It's not that red, it's not that red. would be your color. I wish this would be your color. I wish this would be your color. Your color. I wish it is as black as my livage square, the cold furnace in which we stare, a high pitch on the future scale. It is the starless winter night's tale. It suits you well. It is that black, it is that black, it is that black, it is that black. I wish this would be your color. 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 Your color. I wish.
Close your eyes.